Hello, we are the 2020 Adventium capstone team, and today we will be describing our project. The 2020 Adventium capstone project was a part of a much bigger project under the name of Continuous Architecture Framework for Fault Management Assessment and Design, or as they shortened it to, CAFMAD. This project has been funded by the U.S. Army in development for NASA. CAFMAD would have the role of bringing together data from what is called an authoritative source of truth. This is a system of tools containing trustworthy information from a reliable source. However, the overall goal for CAFMAD is to perform an automated analysis on dimensions of variability in a trade space, with variables being either discrete or continuous. As it turns out, this would be more difficult than simply comparing two components, since dimensions of variability can have complex relationships of varying constraints.
There were a few big picture concepts that guided our design. The first is to consider the dimension of variability relationships and consider how these should be modeled for the user. For example, if analyzing for a casing, the material must be considered and the types of available connectors would depend on the material. A metal casing might have as options screws and bolts, while these would not work for a plastic material. Second, a design space investigation contains analysis scripts. Which of these are relevant for the user and in what order should they run? It might be the case that output from one script is required as input for the next. Finally, an analysis might return thousands or millions of data points, which is just information overload for the user. How can we determine which are the most relevant data that the user cares about? Additionally, the results might contain various data types and dimensions, while typical charts are generally limited to displaying only 3 or 4 dimensions.
The solution to these questions is to create a modular web app containing a widget for each main step of the analysis. Angular is a web application framework with a focus on separating each part of an application into its own module or component, so we would be using this to create our widgets. There would be a widget for selecting dimensions of variability that a user would like to analyze or freeze to keep constant throughout the analysis. Then, in the analysis selection widget, the user could select and reorder scripts they would like to use during the analysis. Once each script is created and a step to perform analysis on, the user can choose strategies for the dimensions they did not select in the dimension selection widget. This could be like examining each variant for a certain dimension or values within a range for a continuous variant. Finally, a results widget can show the analysis with a graph to capture the computed values. All this data is contained inside a design space investigation, which serves as input to the dimension selection widget and is modified from each widget, so the output of one widget would then be the input for the next. And now we will be showing a demonstration of the running application.
This is the basic layout of our application. First up, we have the dimension selection widget, and right now it's empty, so let's change that by giving it a design space to consider. When that is entered, we find that there are 4 dimension variabilities in this latency investigation. So we can select the dimension of variabilities to consider. There's also a search capability, and also if there are significant numbers of dimensions, we can use this pagination. So we will save these and they will be used in the script analysis widget.
After dimension selections have been saved from the previous widget, we will be able to select scripts to run. These scripts tell the program how the analysis will be performed. Some scripts may be shown and not available to use based on the selections that you made from the dimension selection widget, and these unavailable scripts will be impossible to move around or reorder, so they can be hidden using this button right here. In the case that there are too many scripts to show on one screen, there's also a search option or a pagination feature. To select scripts, you just drag it over from all scripts to scripts to run, and when you're ready, you can just save selections. There will be an analysis steps confirmation screen where you can go back and reselect your scripts, or you can just click confirm. Once you click confirm, you can choose your exploration strategies. What shows here depends on the dimension that you did not select in the dimension selection widget. There's a stepping strategy, a try everything strategy, and a sampling strategy. So for power consumption, we can get either a sampling or a stepping strategy. So I'll just do stepping, where I'll start at 1, I'll end at 10, and I'll step by 2. When we click on Save, then it will show you a confirmation screen for the exploration strategies, which you can either go back and reselect, or you can click Confirm to go on to the analysis.
Finally, we have the results widget, so we will give that a results URI, and this will become populated with the data points from the analysis. On the x-axis, we have an enumerated sampling rate, and on the y, we have an itemized processor selection. Hovering over any data points gives us the exact sampling rate, the processor, and the processor's latency. All of the data points are normalized, so they preserve their relative ordering. Larger data points will have a higher latency than smaller data points. Visually, this tells us that there is a significant jump for the 2 GHz processor at around 600 Hz, and for the 4 GHz processor at around 900.
And that concludes our demonstration. Thank you.